Next, we will introduce a new function called the hyperbolic arc cosecant. Let's recall the hyperbolic cosecant of x function and its graph. And let's answer the following questions. Is this function one-to-one? The answer is yes, because it passes the horizontal line test. Does this function have an inverse? The answer is also yes, because all one-to-one functions have inverses. And here's what it looks like. We call this function the hyperbolic arc cosecant of x. However, it is not a new function, and we have seen this function before. So what is the equation of this function? Let's find out. Let's find the equation of the inverse of the hyperbolic cosecant function. To find the inverse, we first swap the x and y in the equation, and now the goal is to isolate the y variable. We multiply both sides by the denominator and distribute on the left-hand side. Then we multiply both sides by e to the power y, and we collect all terms on the left-hand side. Next, we let u be equal to e raised to the power y. So we have the following quadratic equations in terms of variable u, which we can easily solve. To solve this quadratic equation, we use the quadratic formula to obtain the following two solutions. However, since u is positive, we have to discard the solution with the negative sign in front of the radical. Also, we have to require x to be positive as well. Now, since u is e to the power y, then y is the natural logarithm of u. So we solve for y, and we finally get the following result. Notice how we still have the requirement of x being greater than or equal to 0. So for the hyperbolic cosecant function with the following graph and the following domain and range, we found the equation for the right branch of the graph only. Luckily, we can use the symmetry and easily obtain the equation for the left branch of the graph as well. So the best way to define the hyperbolic arc cosecant function is to use the piecewise notation. We introduced a new function called the hyperbolic arc cosecant of x and discussed some of its properties.